Here we are on the shores of Lake Cristobal, situated in the mountains of the South Island, New Zealand. And we're here because the Alpine Fault is located 7 kilometres to the west and dips away beneath us. Now this fault produces great earthquakes, that is, earthquakes with a magnitude greater than 8. And these lake basins are nature's answer to the seismometer, because when the fault ruptures in a great earthquake, the sediments that accumulate in the bottom of this lake record deposits indicative of those really big events that disturb the landscape. So when we choose a lake site to investigate, and the first thing we do is a geophysical survey. And this provides an insight into the spatial distribution of the sediments at the bottom of the lake. So we can identify the best sites to sample the lake sediment by coring it. And then we deploy a Macarth coring system. So the way this system works, we lower it off the side of the boat. It travels down through the water column to rest upright on the bottom of the lake. The coring works by pushing compressed air, which depresses the 6 metre length of core tube into the sediment.
On the top.
To get our corer back, we have to use a salvage bag. And usually the ton of lift force that the salvage bag provides brings the whole system with our intact core, our sedimentary record, to the surface. Typically we take between 3 and 6 sediment cores from a lake. We ship them out of the lake and transport them to the lab where we analyse the sediments.
Oh, beautiful.
Oh, yeah, very nice. So here we've got a section of one of our sediment cores that we've retrieved from a lake. So before an earthquake we have normal conditions and we just have material raining out of the water column, forming the layering that you can see. We have strong shaking produced by an earthquake, and this results in deformation or the buckling and bending of those finely layered sediments that have just recently accumulated. The shaking also destabilizes material on the margins of the lake, producing underwater landslides that form this thick deposit that you can see here. Coarse and dark at the base and becoming finer as we go through the unit. And that represents the occurrence of an earthquake. The shaking not only disturbs the lake, it also disturbs the wider landscape, causing landslides on hill slopes and the production of lots of sediment. Now the rivers work to move that sediment from the catchment into the lake basin, and we can see that process depositing these lighter coloured sediments through here. Over decades, all that sediment is washed by the rivers into the lake, and we have a return to normal conditions. This tiny dark fleck next to the tip of the knife is a leaf in the sediments, and this is all we need to produce a radiocarbon date. And radiocarbon dating allows us to determine the age or when these earthquakes occurred in a precise fashion. And the precise dating allows us to correlate events between sites spaced along 300 plus kilometres of the Alpine Fault, determining how much of the fault broke in individual earthquakes.